mostly talking about impact. Again, previously, like we did in the last section, so the last section, like say maybe two objects ran into each other, like we had like a truck and a car ran into each other, and after they crashed into each other, it was assumed that they stayed together. In the last section, they two objects stayed together after impact. And so we were assuming in that case. Now we're going to cover that case plus a case where when they rebound. So in this section, we continue to study objects that impact and stay together. As well as objects that bounce. And we maybe should say as well as objects that separate after impact. And so that's what we're going to do in this section. And one of the things that we're going to add this time is we're going to have the coefficient of restitution, which you probably had this in physics. Coefficient of restitution, and that's it's represented by E. And it's the, let's say if you have two objects, say that are come together, let me do a picture first. So let's say you have two objects, say maybe A and B, and let's say that they collide with each other. Then the coefficient restitution is equal to VB2, the velocity of B after the impact, minus the velocity of A after the impact, which is indicated by the 2, which means after. And then divided by the velocity of A before impact, minus the velocity of B before impact, like this. So that's the coefficient of restitution. So we're going to use that. And we're also going to still, so this is the new thing that we're going to have. We're also still going to use a conservation of momentum. Which is, say, MA VA1 plus MB VB1 equals MA VA2 plus MB VB2. And often, and so keep that in mind, that was from the last section, and also often we'll need work energy. Remember, work energy was T1 summation of the work from 1 to 2 equals T2. Next, we're going to look at this problem,
15-60, 15-60. Disk A has a mass of 2 kilograms. It is sliding forward on the smooth surface with a velocity of 5 meters per second when it strikes the 4 kilogram disk B, which is sliding towards A at a velocity of 2 meters per second with direct central impact. If the coefficient of restitution between the disks is 0.4, compute the velocities of A and B just after collision. So we have to find the velocities just after they collide.
And so we have one that's 2 kilograms moving to the right at 5 meters a second. And the other one moving to the left, and it weighs 4 kilograms. And it's moving to the left at 2 meters a second. Let me slide that up. And again, call this A and this B. And again, it's on a smooth surface, so it doesn't have to, we don't have to worry about friction. If the coefficient of restitution is 0.4, compute the velocities just after collision. So we're given the coefficient of restitution, so let's write down the equation VB2 minus VA2 divided by VA1 minus VB1. And we're given E, so we can plug that in. And we're given that, again, if we call positive moving to the right, I'll call positive moving to the right. So if we use that, then for VA1, that's going to be a positive 5. For VB1, that's going to be a -2, huh? So we have 2 unknowns in one equation, so we can't solve this yet. So this is going to be 7. If we multiply 7 times this is going to be VB2 minus VA1 equals 2.8. And so we'll call this maybe equation 1. And again, so we need another equation. So we can use conservation of momentum. MAVA1 plus MB VB1 equals MAVA2 plus MB VB2. And so now we can just plug everything in. We know the mass is 2. The original velocity is 5. For B, we know the mass is 4 kilograms. And the velocity is -2. Mass of A is 2. VA2. Mass of B is 4. VB2. Like this. And so so there's several ways you can do this. Again, this is going to be our second equation. So we can maybe solve this equation for something and put this in equation 1. That might be a good way to do this. So we could say, let's rearrange this a little bit. If we work this out, this becomes, this is just 2 here. And so that's just 2. If we bring VA to the left, so we're going to end up with, and then bring this to the right, that'll be 2VA2 equal or actually I'm gonna sort of keep this here and then move that over here. So it'll end up being like 2 minus 4b2 like this, huh? And then we can just solve this for VA2 is going to be 1 minus 2VB2. And then we can put this back in equation 1, huh? Wait a minute. I did. No, back in equation, I made a mistake on the equation 1 here. This should have been a subscript 2 right there. Fix that right there. That should have been a subscript 2. So now we can put this back into equation 1. So put into equation 1. And when we do that, put this back up into here, we get VB2 minus 1 minus 2VB2 equals 2.8. And so we end up having, this will be a positive 2VB2, 3. So that's going to be 3VB2 minus 1 equals 2.8. And if we divide both sides by 3, we'll get VB2 equal to 1.27 meters per second. And since it's positive, that'd be to the right, huh? And now if you put this one back into any of the other equations, so let's say we'll put this back into equation 1. We get VA2 is equal to negative 1.53 meters per second. And since that's negative, that's to the left.
Next, we're going to look at this problem 15-59. 15-59. And this is similar to the ones we've seen before, except this time the truck is going to collide with a car. And instead of locking together after collision, they're going to separate. So let's take a look at this. It says the 5 megagram truck and the 2 megagram car are traveling with a free rolling velocities shown just before they collide. You can see there one's 30 kilometers per hour, the other one's 10 kilometers per hour. After the collision, the car moves with velocity of 15 kilometers per hour to the right relative to the truck. In other words, and that's important to understand that after the impact, the car is moving to the right 15 kilometers per hour relative to the truck. That doesn't mean it's absolute speed, but that means how fast it's moving away from the truck, 15 kilometers per hour. And determine the coefficient restitution between the truck and the car and the loss of energy due to the collision.
So again, you're gonna have something like this. Gonna have a truck. Again, it's if you work this out, 30 kilometers per hour is going to be equal to about 8.33 meters per second. And it's moving to the right. And we'll call this, I'll just call this A. This is going to be the truck. I'll just call it A. And it's 5,000 kilograms. And the car is 2,000 kilograms. Call this B, and that's the car. And it's moving at 10 kilometers per hour, which is around 278 meters per second. And so again, they're going to collide. So A is going to run into B, and then they're going to separate. And so there's a collision, then separation. And it's hard to say, let me sort of look ahead. Looks like if you calculated, what's going to happen is they're both still going to move forward. Yeah, we don't know that yet, but when you do the numbers, we'll find in a minute that that's true. And then we're told that car A relative to, the car B relative to A, let's see, yeah, VBA is going to be 15 kilometers per hour. After the impact. In other words, they're both going to kind of be moving forward, but this is going to be moving away. The car is going to be moving away from B at this speed. And if you work that out, that's about 4.16, 4.167, 4.167 meters per second, that the car is going to move away from the truck after impact. And so that's going to be the relative velocity. And so what this is going to mean, though, so after impact, this is going to happen. And what that's going to mean, so this means that, say, VB2 minus VA2 is going to be equal to 4.167 meters per second. Is what this amounts to. In other words, it's going to be car B, the difference between the speed of car B, which is the car relative to the truck, is going to be that difference. That's going to be the difference. So we know that much. So we can use this to find our coefficient restitution. And so we can find our coefficient restitution. Remember, that's VB2 minus VA2 divided by VA1 minus VB1. And so we know what this is right here, so we can just put that in the numerator, 4.167. And then the velocity of A before impact is 833. The velocity of B before impact was 2.78. And this is 0.75. So that's our coefficient restitution. So any questions on that so far? And now to find, so that we also want to find the energy loss. So to find the energy loss, we're going to have to use the conservation of momentum. Again, so we're going to want MA VA1 plus MB VB1 is MA VA2 MB VA2. And then we can just start substituting things in. 5,000 times 8.33 plus 2,000 and 2.78 equal 5,000 times VA2 plus 2000 times VB2. And let's see, and then what we're gonna have to, substitute what we had before. We had that VB2 minus VA2 is this value. So substitute, in other words, use this up here. And so you could solve this for VB2. Substitute VB2 equals VA2 plus 4.167. And so in other words, we'll substitute that up here. When you do that on the left side, if you multiply all these numbers out, you get 47,210. And on the right, we're going to have 5,000 VA2 plus 2,000. Then after we substitute VA2 plus 4.167, like that. And when you put all these together, I won't go through all the steps, but if you put these together, you'll end up with like 7,000 VA2, then multiply this here and bring that on the other side, and we'll get VA2 is 5.55 meters per second. And then if we put this back into this equation, we get VB2 equal 5.55 plus 4.167 is equal to 9.72 meters per second. So now we need to find these again. So that's, yeah, so of course those are both positive, so they're both going to the right. So we need to find those so that we can use conservation of momentum, or excuse me, to find the energy loss. Find energy loss. And so we're simply going to find the energy before and after the collision. So before we look at, say, all the energy. So it's going to 1/2 MA VA1, 1/2 MB VB1, and put those values in the half times 5,000. Then we just found the velocity is 8.33. And times 9.72 squared. And so before impact, we had 181, around 181,201 more or less. And that's going to end up being kilograms meters squared seconds squared. I think that's probably joules. I don't use joules too much, but I think that ends up being joules. So then after collision, we have T2 is 1/2 MA VA2 squared, 1/2 VB2 squared equals 1/2. Once again, that's 5,000. And then our, I made a mistake. Let's see. By the way, back right up here, this number is correct, but I wrote the wrong number up here. This 9.72. That should have been 2.78. I'm sorry. That was before impact. 2.78 squared. Yeah, fix that right there. This number is correct because when I calculate, I used the correct number. If I wrote it wrong here, please fix that. So then after impact, 5.55 squared plus 1/2, 2,000 times 9.72. Here's what 9.72 squared should be right there. And this comes out to be around 171,485 with the same units. So we'll have to see the change in energy. So the energy loss is going to be equal to T2 minus T1. So that'd be this one minus this one. And when you put in your calculator, around 9716 kilogram meters second squared.
A 1 pound ball A is traveling horizontally at 20 feet per second when it strikes a 10 pound block B that is at rest. If the coefficient of restitution between A and B is 0.6 and the coefficient of kinetic friction between the plane and the block is 0.4, determine the time for the block to stop sliding, for the block B to stop sliding.
Object, I'm not sure what the shape is. I'll just make it like this. So again, it's 1 pound. And it's moving to the right at 20 feet per second. And again, I'll call this object A. And then there's going to be a block over here that weighs 10 pounds. Block B, and it's at rest. So like say step 1, it's going to be something like this. Then step 2, there's going to be some kind of an impact here. And so it's going to impact it like right here. So they're going to contact for a while. Then they're going to bounce off each other. So number 3. They're going to go each on their own way. Now, I guess I'm not sure yet which direction A is going to go. Let me just put a question mark for this direction. So I'll just put question marks. It could move to the left, maybe to the right. Not sure yet. But definitely B is going to be moving to the right because it was at rest when it was struck. So we have to, so we're going to have to do this in steps, really. So we're going to start with using the coefficient of restitution. So again, go through this, what I marked step 1 here. So step 1 is when they're kind of moving on and they're going to actually end up impacting each other. So this could be like step 1 or step 1 and 2. And so use a coefficient of restitution. I won't write everything down again. Remember, it's VB2 minus VA2, VA1 minus VB1. So I'll put VB2 minus VA2. And then for the original velocity of A was 20. Original velocity of B was 0. And then we're told also that our coefficient of restitution was 0.6. 0.6. So we can solve this, get maybe VB2 is equal to 12 plus VA2, and we call this equation 1. So we'll call this equation 1 here. Just like before, we're going to also need the conservation momentum. Which is MA VA1 plus MB VB1 equals MA VA2 MB VB2. And just put everything together. Remember, of course, we're dealing with English units now. So for mass, we're going to have to divide by 32.2. And then VA1 was 20. And remember, the block B was at rest, so that's going to be all 0. Right-hand side, 1 over 32.2. VA2. And then block B was 10 divided by 32.2. VB2. And if you work this out, you'll end up getting VA2 equal 20 minus VB2. And what we can do, let's see, we can solve this several ways. We can maybe put this into equation 1. So put into equation 1. Now let me change sheets here. And when you do that, you get VB2 is 12 plus 20 minus VB2. And then when you rearrange this and solve, you get VB2 is equal to 2.91 feet per second. Then put that into equation 1 and solve for A. Then VA2 is 9.1 feet per second. So actually this was, I guess that was really step 1 and 2. So we found, we have the block, we found the impact. Actually, it looks like they're both moving to the right because they're both positive. So, so after impact, let's see. Wait a minute. Doesn't want to, you know what? This has to be negative. Yeah, sorry. This has to be negative here. Yeah, this is negative when you put in the equation. I was going to say that could hardly work if they're both going to the right and A was going faster than B. But if you work this out, that will be, when you put this back into equation 1, this will come out negative, yes. So that would be to the left. So what we have then after the impact, A is moving to the left at 9.1 meters per second to the left because that's negative. And then B is moving to the right at 2.91, sorry, not meters per second, feet per second, sorry. Feet per second, like this. So that's what we have after the impact, is that A is moving to the left at 9.1 feet per second. B is moving to the right 2.91 feet per second. And so they want us to find the how long it's going to take to stop. So if we focus on B, so So focus on B. And think, what kind of forces do we have on B? It looks like the only thing we have acting on B is going to be the friction force, huh? If we look at B, so once B starts moving, this really just becomes a problem like we've had before. We have friction acting on B, and it's moving to the right at 2.91 feet per second. Only force acting is friction. And so we could use, again, since they've asked us for time, we want to use impulse and momentum. If they would have asked us for distance, we would have used like work energy, huh? If we wanted just the distance, we would use work energy. But since they've asked us for time, we'll apply impulse and momentum. So again, think what we have here. So we have 10 pounds. And again, this is going to be reacting with 10-pound force here. So our friction force is going to be mu times 10, which in mu is given as 0.4 times 10. So our friction force is going to be 4 pounds. Is going to be our friction force. And that's really the only force we have on here. So if we apply impulse and momentum, again, remember that's like M1 V1 plus the integral of f dt equal M2 V2. But notice the only force is friction and it's constant, right? So we really don't have to use the integral. So we can do like 10 over 32.2, and V1 was 2.91. And again, plus the friction force, which is constant. And so let me just put there friction force, and then just times delta T. Again, we're allowed to make that change. We can get rid of the integral because the friction force is constant. And then the final velocity is supposed to be 0. And if you multiply this out, this is 904. And then our friction force was 4. Delta T is 0. And then if you solve that for delta T, you get 0.226 seconds. Oh, yes, that's right. Oh, yes, actually, yeah, thank you very much. Actually, yeah, so this friction force here should have been negative. Yeah, fix that up there. Then this would have been, these would be negative here as well. Yeah, it looks like somehow miraculously I got the sign right. I did write it correctly here, but these definitely should be negative. Thank you. Because remember, friction is always working against the direction. Yeah, so please fix that. The way I wrote the answer is correct.